Hi guys, welcome back to another video. So in this video we'll be solving this problem, friend groups. It's a medium level problem. So let's see the problem statement. You are given an undirected graph. Friends is an adjacency list where friends of I is a list of people I is friends with. Friendships are two-way. Two people are in a friend group as long as there is some path of mutual friends connecting them. So return the total number of friend groups. So this is a graph problem. So let's see the sample. This is a graph, so 0, 1 and 2 forms a group, 5 alone forms a group, and 4 and 3 forms a group. So output is 3. Okay, so let's see how we can solve this. So we are given an adjacency list or graph. Let me give a clear explanation of what is adjacency list, like how it is used to represent a graph. So let's suppose we are given this, and it is in the form of 2D array. So at 0th index, suppose there is a array at second, third, and fourth. So in this index represent the number of, like this index represents the node. Like this is a 0th node, this is a first node, this is a second node, third node, and fourth node. So the length of this list represents how many nodes are there in the graph. And the array, like in zeroth index, there is an array. So so the number inside that array represents how many nodes are there which are connected to that index node. Like zero is connected. Suppose zero is connected to one and two. So there will be one comma two. Like one is connected only to zero. So and there will be only 0, like 2 is connected only to 0, so there will be only 0, and 3 is connected to 4, so we'll write only 4. 4 is connected to 3 only, so we'll write only 3. And suppose there is also 5, and 5 is not connected to any node, so it will be an empty. So this is how we represent a graph using adjacency list. So we are given this in the problem. So let's again write our graph. So this is our graph. So we will use we will use DFS, depth first search, to solve this problem, and let's see how we can use that. So we have to only find the number of groups, like we can say the number of connected components. We have to find the number of connected components, so we will use DFS to solve this. How we can do? We will create an array or vector visited, and the length of that will be n, which is the number of nodes, and we will initially mark all to 0. 0 will represent that node is not visited, and 1 will represent that the node is already visited, so we don't have to process it again. So let's see, suppose we have to run DFS for every node which is not yet visited. How? We'll apply a for loop. We'll apply a for loop, and we will check if visited of I. This I represents the node, number of the node. So if visited of I equals to 0, that means it is not yet visited, so we will run DFS. So let's see what our DFS will do. So suppose the first node is 0th node, so we applied DFS for this node. Okay, so our DFS function, what will do, will mark this, it will mark this node as 1, visited will be 1 now, so we don't have to process this node again. And what we'll do, we will apply a loop to every other node which is connected to it. Like 0 is connected to 1, so we will check if this node is already visited or not. If it's visited, then we will not apply DFS, we will not run DFS for this node. And if it's not visited, we will run DFS for this. So our DFS was for 0, and now our DFS will be for 1. So our DFS will run for this node now, so our DFS function will mark this as visited, and 1 is connected to 0 too, so a for loop will run for 0 and for 2. So for 0, will it will check if this node is already visited or not. So it's already visited, so it will not run again another DFS. And for 2, it is not yet visited, so our DFS will go to 2. It will mark it as visited. Now again it will check for the connected node, so 1 is visited, so we don't have to process it again. So and it's only connected to 1, so after that loop it the 2 will got this DFS function will get over, it will come to 1, so DFS 1 will also get over, it will come to 0. 0 is not connected to any other node, so it will also get over. So our DFS function will get over for 0, and we will and then we will increment our answer plus plus. Initially our answer was 0 and answer was 0. So we got our first group, so answer will get incremented to 1. And similarly our loop will now proceed to 1, and we will check if visited of 1 is equals to 0. So it's not, it's visited is already 1, that it depicts that this node is already processed. We have taken this node in a group, so we don't have to again apply DFS to it. We don't have to process it again. So our loop will go to 2. 2 is also already processed. So we will now go to 3. So 3, we will see that 3 is not yet visited or it's not yet processed. So we will run DFS for this node. And similarly, this and this node will get visited. So we will get another group. So we'll again increment our answer. So answer will was first 0, then it gone to 1, then it gone to 2. And similarly for 5, it is not yet visited, so we'll run DFS for it, so it will also get visited. And similar, and our answer will go from 2 to 3. So our loop will get over, then we will return our answer. So in this way we'll get the number of groups which are present, with number of friends groups or the connected components. So this is the approach. We have to use DFS, and we have to run DFS for every node which is not yet visited. So that's the approach. Let's code the solution out. So let's so the length of this adjacency list will represent the number of nodes. So we'll store it in n, and we will create a vector visited which is of length n, and will mark every visited to 0. That means all the nodes are not yet visited, and we will create a loop, and we'll check if this node is visited or not. If it's not visited, like it's 0, so we'll run DFS for it. We'll pass this 3 parameters, and then we will run DFS for it. So first will be a node, and then and then will be a visited. Then we'll mark this node as visited in our DFS, and then we will traverse through the nodes which are connected to this node, current node. So friends of node. So if visited, let's take the name J to it, which are the nodes which are connected to this node. If visited of J equals to 0, then we will run the DFS for this. Like this is not yet visited, so we'll run DFS for it. Okay, so that was the code for DFS, and we will increment our answer plus plus, that if we got a group after marking that all group 2 visited to 1, we'll create an answer equals to 0, and then we will return the answer. So this is all. So let's run. So we got accepted, we got the answer 3. So let's submit. Okay, so we got success. So just we are running DFS for every node, and we are marking it as visited so that we don't revisit a group. So the time complexity for this was just O of n, where n is the number of nodes. So this was all about this problem. So thank you for watching, and I see you in the next video.